Now like to invite Pete Baxter, VP Sales Americas Autodesk, to present the future of design and manufacturing.
So I started my life as an architect. And I remember when I was studying the classic architects, I was actually somewhat surprised to find out that they didn't just design buildings and draw stuff. They actually were makers. They were sculptors, they were artists. They also quite often invented the machines that carried the big lumps of stone to the tops of domes. In short, their role was far broader than it is today. So it's really exciting for me to talk about manufacturing, because actually what I'm going to talk about is phenomenal change that's happening in this market, and how we're on the cusp of something really, really exciting. So the opportunity is for all of us. Every one of us who's in design, every one of us who's in manufacturing, there's an opportunity to fundamentally change our relationships with our customers, to think differently about the problems that we're asked to solve, to come up with solutions that delight and excite our customers and exceed their expectations. We want you to be prepared for the future. I want to talk about that in three ways. Firstly, being able to develop great breakthrough products that are smart, that are connected, that are configured, and match and exceed the needs of your customers. Secondly, it's about leveraging new materials, new manufacturing technologies, automation, and production methods. You know, think about it. A lot of the constraints that we've all had to deal with have been around methods of manufacture. You saw the example of Additive at General Motors and what they've been able to do to consolidate assemblies down to single parts, something that wasn't possible. You know, the opportunity that opens every one of us as designers is really, really exciting. And the third is about helping you move beyond CAD, not just thinking about CAD as the documentation tool, you know, whether it was 2D or 3D or whether it had some simulation capabilities of it, but actually thinking about software as a way of making the engineer and the designer smarter. It's about actually leveraging the computational power of the cloud, and let's face it, processing power is still the cheapest and most available raw material at our disposal today. It's really, really exciting times for us to think fundamentally different about the way we design and make us all much, much smarter. So let's look at three examples of our customers, of how they're thinking differently about design. So we got the next slide, please. Right. Okay, this is a UK customer called A-Safe. They design safety barriers, not the most exciting product you may think. You know, it's just lumps of metal bolted together that stop vehicles crashing into expensive equipment. But actually what they've started to do, what this customer A-Safe in the UK has started to do, is think very, very differently about the whole design here. Firstly, because of the materials that are used, an impact doesn't cause a failure of the product. It may not even create a need to update or change the product or replace something. Frankly, there are sensors in these barriers that enable them to monitor whether or not something needs to be repaired or not. But it actually goes further than that, because they're also able to collect the data, look at where the biggest collisions are, think a little bit about the way that the factory is laid out, think very differently about the design of the factory and the positions and design of the safety barriers. You know, it's having those sensors in the equipment that's giving them access to a lot more stuff. So taking something very mundane and adding a lot more value to their customers. Second one. Now, this is a a great example. It's something that I was involved in during my time working with the Delcam team. You know, Delcam was an acquisition that Autodesk made about 5 years ago. And this really takes a smart manufacturing process to a closed-loop production process. Essentially, what we're doing here is a closed-loop automation. You know, automation's been around for a long time, 60s or 70s, but what this is actually doing is really taking 3 or 4 separate tasks that were somewhat manual and automating them. Here we see a machine combining different processes, and if we can run the video. But turbine blades, as you probably know, whether it's a jet engine or something else that spins very fast on a piece of equipment, it's the leading edge that typically gets damaged. You know, it ingests dead birds and bricks and all sorts of stuff like that. So the repair process is actually about removing the damaged leading edge. It's about adding new material on in an additive process, and then it's about grinding that down and polishing it to get back to the refined, perfect product that we started off with. Now, particularly adding the new material is not a precise process. So once that's added, we need to know on every individual instance what needs to be removed. And this is where robots and learning comes in, because essentially what we do here is use a robot arm and probes to define the exact extent and then generate the toolpath on the fly to make the exact alteration, the exact work to that part that's needed. The interesting thing is every single part is different. So you might be doing hundreds of these, but it's not just every single toolpath, every single machine action is different. It's specific to that part. And that's really, really clever and really smart, because what it enables us to do is to start thinking about manufacturing, not about just producing tens or hundreds of thousands of identical parts, but modifying things on the fly. The machine, the software is generating the toolpath code, the G-code, to make the changes necessary for every single item, every single instance. Really, really impressive. So the last one is about the nature of work. In the past, engineers documented their ideas, whether it's in pencil and pens and 2D CAD and 3D CAD. And then we do simulation. So they got progressively better, but there's a sea change starting to happen. Here's an example with Stanley. They needed to design components, tools, that were going to be used at a height, and obviously had the risk of falling and potentially hurting someone. So their goal really was to think about, they had to produce something that was strong, and they had to produce something that was lightweight. Two things that typically don't go too well together. But this is where generative design and additive manufacturing came in. Using the power of cloud computing, they were able to generate thousands of different options that the designer could then choose which one to go for. What they were able to do, we moved from them thinking about documentation to the engineer defining the problem. What is it? It's strength, it's weight, it's ergonomics, it's center of gravity. By putting those in as the design problems to solve, software was then able to go and do it for them. Look, they came up with something that looked fundamentally different, but something that was exactly fit for purpose. The weight saving was over 50%. There was no compromise on strength. Perfect example. This is really where we want engineers to focus more on defining the problem. That's the big change that we're talking about here in design and manufacturing. It's going away from documenting design to defining the problem and using the power of the software and computers to solve those problems for you. So how do we get all of this in your hands? Well, many of you are long-term customers. I hope all of you are long-term customers. You use various products from LT through to Inventor, and hopefully many of you are using PDMC, Product Design and Manufacturing Collection. A lot of the stuff that you've seen through today and the stuff that I've just talked about is available to you in PDMC. So let's just look at actually what we've delivered in these products to help you be more successful. So Validating your designs at an early stage is becoming more and more important. Products are becoming more complex, new materials, new manufacturing technologies are being used. Time is of the essence, we all know that. Everybody wants to be able to simulate. You want to be able to look at the performance to make sure that it's fit for purpose. And you have to do that quickly. Let's think, you know, if you make the wrong decision late on in the design, it's really expensive to change. We all know, you know, 80% of the cost is committed at 20% into the design phase. So the earlier you identify issues, the better that you're in a position to respond to them. So the simulation tools that are available in the cloud through PDMC will enable you to do that. The power of the cloud enables you to be able to run those simulations at a very early stage and make those right decisions. Every PDMC customer has access to this. As an engineer, you can leverage the power of the supercomputer, but it's all on demand. It enables you to shift from exploring and optimizing a few design options to look at many different design options. And clearly, that's what we all want to be able to do. And you can focus on designing the problem and using the algorithms in the software to enable you to come up with the best solution. It enables you to enter a new dimension in terms of performance. So, and of course, once you've defined and developed the design, knowing with confidence that it will be fit for purpose, we've also added in CAM capability. Whether it's 2.5 axis, or 3 axis, 3+2, or 5 axis, fully integrated. Straight from the inventor model, you can produce the G code, all managed within a consistent Vault experience. So the two are just now really closely linked. Before, design and manufacture was a separate process. Now it's all connected. It's important that, you know, none of us are paid to produce pretty pictures on a screen. We're paid to make stuff, to design and make stuff. And this integration of all of this capability is essential to ensure that we can exceed our customers' expectations and deliver them on time. You know, who's ever had a customer that said, you know, take all the time you want, you know, deliver the design whenever, there's no pressure. That doesn't happen. We're under cost pressure, under time pressure, and the integration within PDMC will now enable you to do this. But it doesn't actually stop there, because actually what we also want to be able to do is have links to all aspects of manufacturing. So Sheetmetal Nesting is also incorporated in the PDMC. That enables you to actually convert the schedule into the most efficient cutting schedule. So it's about more, better, but with less material. It enables you to adjust the design to optimize it, not just in terms of performance, but in terms of manufacturability. The nesting utility that's now in Inventor will allow you to optimize that sheet layout. Of course, we can add all the functionality we want into the products, and hopefully some of you have already experienced that and are getting a lot of benefit from using it. But ultimately, it's about experience, isn't it? We're all designers. The user experience is really important to us. We know experience means a lot and can make the difference between something being okay and something being an absolute delight to use. So, you know, what I can tell you is that within the product, within the Inventor product, within PDMC, we've actually put over 240 enhancements into the product in the latest release. So a lot of our focus and effort continues to be focused around Inventor as the core of PDMC to ensure it meets and exceeds your expectations. And that's the platform. It spans from design and engineering through documentation and manufacturing. It allows you to get higher efficiency by automating your engineering processes, to accelerate design with specialized modules like frame generator, routing, piping, and to manage data and processes. It brings next-generation methods like generative design to your fingertips. It also allows you to break down walls between departments so you can have better integration of tasks and functional groups within your organization by sharing the same data set. and establish true collaboration within the firewall and beyond to your extended supply chain. And you can plan your factories, simulate all aspects of the manufacturing process to ensure that you can make what you've designed, that you can do it within time, and you can do it within costs. So Autodesk tools enable our customers with more innovation and higher efficiency. The stuff that you've seen on main stage, the examples I've shown today, are all leading edge. Sure, they're using new approaches, they're using new technologies, but the key thing is this is where the industry is going. If you think that your role as a designer is simply to design and produce graphics, a graphical representation, you've missed the point. But more importantly, you're probably going to find yourselves left behind. You need to be thinking about that fully integrated process. You need to think about the potential of additive manufacturing. You need to think of the potential of new materials, how that's going to help you be even more successful in the future. I said at the start that I was excited by this integration of design and manufacturing, something that I've thought about a lot. We can see some fantastic examples from our customers. It's absolutely going to be the future, and I, as many of us in this room, I'm sure, are totally excited about the opportunity that this brings to our industry. Thank you.